We also split Estonian kind of introduction into geological and geophysical part. And my first kind of part of this presentation, the geological part, is based on a lot of history of Estonian studies, not so much a lot of history of the basement itself, but I try to give an overview what we know and what has been known. Sometimes it's important to select or divide what we know and what has been known, because the invention of wheel is probably not wise to do it very often. Some words about myself. I got into Precambrian geology business when I was doing my thesis, 5-year thesis. So I graduated in Soviet Union. And people here graduated in the Soviet Union. But it was still Tartu University, so Finnish, or not only Finnish, but Latvian and Lithuanian people also know Tartu University. And it was nice to learn that so much cooperation has been already done between Latvia and Tartu. Then I was unlucky because that period was not so successful anymore for basement, crystalline basement studies. So early 90s, I had to take a travel around the world. I would say I spent outside of Estonia for 8 years, but still everywhere, mostly working and studying crystalline rocks, and in most cases also quite old one. And then I came back to Estonia 2001, and after that time, I have been involved in Precambrian studies, but a lot of other stuff has been ruined my life, in soft meaning. So, okay. This one.
Slide. No, the slide first.
Just slide. Okay.
Yeah, and then you.
Okay.
That's perfect. I'm confused.
Okay. This is already working. So when we talk about what is our purpose, the larger scale purpose here is to come up with Estonian geological map. Is to come up with Latvian geological map, and it's to come up with Lithuanian geological map, and then merge those things together. If we can create another geological map of Baltic states, then we can merge to this already colorful part of the world in north of us. But we have quite different levels because it's difficult to compete Finnish people, and sometimes also difficult to compete Swedish people, but Swedes are now a little bit more easy. But why? Probably this is kind of historical chart of minings and using of metals from the earth. And a few years ago, we had in Estonia conference on mining, Estonia mining 100 years. Wow, it's a long history. 100 years mining, it was just oil shale because there's nothing else has so long history of mining. And then I was talking to the Finnish people, and they said 100 years, like, yeah, we have 500, and Swedes came in. Oh, 1,000 years we have experienced and mined for everywhere and everyone. So mining is that which gives also our key to continue studies. I would say these CRMs, critical raw materials, are the key if we want to continue this crystalline rock studies. But what we have, it was really nice to see. It's a shitty quality, but probably you can still see it. There's lots of maps also in Latvia done, but this was one of these compilations which was a little bit later, a Pirkis ones. Pirkis in Latvia was before 1980. But this is compiled by Väinö Puura and others, and Pirkis and all these people. And in that map, oh, we don't have this pointer here. In that map, why I like that map very much is pinkish color is all Archean stuff. So we had a lot of Archean stuff, and so the map was published in 1980. So if we could now publish similar map, not with Archean rocks, but without Archean rocks, but similar map in 5 years, I think it would be really great and make a real map according to the latest knowledge. But this was good introduction, and it took 11 years. I think the first paper came out by Hannu Uhma and Väinö Puura, saying that we don't have Archean rocks here at all, because they run a couple of samples for submarine neodymium isotopes and discovered that yeah, now we are free of that. So, and I would say the most active basement studies in Estonia were during 60s and 90s. After 90s, everything looked to cool down until 2018. I really want to mention that that time. So Estonian Geological Survey was established. So Estonian Geological Survey has history of nearly 80 years, but the governmental body was established, and we could fit in basement studies there. So from that point, we are much luckier with these things. But still going back to 80s, how many people have this book? Okay, how many people can read still Russian? One. Okay, 5. Okay, I call it manual, or you can say it's kind of not everything. So it's a very good compilation of what we knew by 1983 or even 1980s. So I have been reading this book and using this book, and what good thing happened next in this order was because Finns got really interested in Estonia, because they discovered that we don't have Archean rocks, and there is kind of white sheet. They can discover lots of things, and this Koistinen group actually published a geological map of southern Finland, and northern Estonia or central Estonia was also fitting in. The map looks like this, and yeah, Latvia has some parts, but mostly cut off, and southern Estonia, very southern Estonia is also cut off. But good thing with that map is that we got over the Finnish Bay, and so we imagined. I'm not author of that, but I still use we. We imagined how the rock looked like under the sea in the north and in the west. So I would also say that we managed to publish a compilation of Estonian basement studies in 2004. So it took 2 years to collect papers, available papers by that time, compiling everything, what was new, but mostly old stuff. We put in kind of renovated kind of fashion. So we came up to this official geological map, which is hanging also over there. in a full size. This is a compilation 92, 2002, I think. And why I don't like this map very much, if someone has a very good vision, can see these dark dots on the map. Those are drill holes, location of drill holes. So we have like in Latvia, you have lots of drill holes in the western side. We have in the northern side altogether maybe 300 we can study still. More same number in Latvia, more or less.
Latvia is 200.
207, but Paul is from less, much less.
Yeah. So why I don't like this map? Usually people kind of establish their kind of evolution to make more detailed things, but I don't like these detailed things, especially in southern Estonia. So since you see very little black dots, drill holes there, but we have very detailed map understanding. So I would like to have this map much more simplified. And then 2015, I was really happy. Svetlana Bogdanova really put 2 years of work and with the team published this kind of large-scale paper, which also deals with Baltic states and kind of until the Ukrainian shield. So we got in and we still don't really, we are quite agree with these distinctions of the different units. So I'm happy with that, but of course we have to redefine very minor things there. Then it took some time. Jansson was really happy, Swedish, who wanted to see kind of even larger scale pictures. This is a paper you can find in Precambrian research. It's a very detailed one around the globe. So that's interesting. And Estonia and Lithuania are also in with the data. And we are happy that we fit in also these magmatic events in here quite a lot. So for today, in Estonia, we have really more or less finished extensive digitalization of previous data. And of course, in some cases, digitalization is just a scanning of reports, and we have 800,000 pages of reports scanned, so they are available. You can go and check and download all this stuff. So our drill cores are now, I would say, neatly organized in new core sheds. And CRM helps us. So we go to ministry and we say that Precambrian geology is very important because there are so many metals in Estonian basement. So, and this new field station looks completely different. This brownish wall building is only the old one in this picture, where the drill cores were kept. Now we have a lot of new ones, now even more, and this central house as well, and there will be another house very soon. And now the life goes on, because now it looks like quite a number of new active people trying to put their input in Precambrian geology studies. And we are publishing different kind of map compilations, reducing kind of details, sometimes putting something new in, but the new is mostly interpretations because we have so little new drillings, a few drill holes. We use this old metallogenic information to build up understanding what we should provide to the ministries, because we need to ask money. But we are also doing something new. It's Estonian Geological Survey has a core scanner, quite a nice one. So we can scan through cores one by one, and get the metals, interested metals out in some, I would say, good quality. So these at the moment, the targeted systems are like nickel, copper, chrome, and molybdenum, and so on. Also gold and silver. And I would say this is a new era because we can also produce quite new maps. Those red dots there indicate kind of intervals where you have certain mineralization indicators or the element contents above certain levels. So if the larger the unit size in meters, the larger the kind of dots there. So this is kind of new understanding. I'm really happy that we are now also producing some new information, not just analyzing, reanalyzing the old ones. And if we look this latest application kind of articles, this is kind of output of our knowledge. This is not complete list, but a few here. I know many our people are already submitted new papers like Synergy, and we have a good PhD student at Baltic, Joanna, who is very active in publishing, and the poster about new models compiling also in Estonia and south of Finland is also available there. But now going a little bit back to understand the Estonian basement as well. So we are agreed that we are dealing with Cyclophenian origin here. So we are not really going back to Archean. If we see Archean sequence, that's all okay. But mostly we are sitting within this origin. And like in Latvia and Lithuania, Estonia is also sloped towards south. It's a north-southwest section, cross section, and Latvia starts somewhere here. And we see that we had already in Devonian, we had this boundary between Estonia and Latvia. It's a physical boundary. So we were protecting, not dinosaurs were not there yet, but some fish. Yeah. So, but sedimentary wise, in North Estonia, 200, 250 meters, you have drill to get the basement rock. In South Estonia, 600 to 800. So it's not so bad as in Latvia, and much better than in Lithuania, but it's still quite deep. And some new compilations here, Synergy submitted with new nice pictures. So I am showing this zoning picture here to talk about Estonian kind of structural zones as well. Probably this is already too colorful. I show my 20 years old one. So what we do, we have two major units. This Baltic deformation, Skov deformation zone is separating something. This is very distinctive. And then we have east-westward also Saaremaa zone, which is also separating something, but which is not so distinctive. So all southern part from this eastern, say, southern part of this deformation tectonic zone is mostly granulitic facies rock. The eastern part it's also shared by this east-westward shear zone. We don't know actually is it a shear zone, but we know that it's a tectonic zone at least. This segment is actually retrograde granulite facies rock, so it's retrograde rock. What above that zone? It's a Tallinn zone, Alutaguse, Tapa, They are amphibolite, mostly amphibolite metamorphic rocks, except Yofi, when you get also slice of granolites and a few pieces somewhere here also popping up these granolite spaces throughout. So it's quite intriguing to make a bigger picture of sand, but I think we are able to do and modify this nice crystalline basement map as well, because the number of rock units is already decreasing. So we started with how much there was? Seem 24 or something like that, where the first maps were made. We had 24 rock types. Now we are really decreasing this number of rock types, and we are getting closer to the truth. I hope so. So one specific feature in Estonia is also the because of drill cores and drillings, we can really study weathering crust. And in Finland, we always talk to Finnish people that you don't have one very specific geological feature. You don't have weathering crust. Yeah, we don't have, but we have here. I don't know about Latvia and Lithuania. Maybe it's a good idea to also to make kind of 3-state compilation of this, because this is kind of secrets map the thickness of weathering crust. And as you see, in some places you have more than 100 meters of this weathered rock types with different things. But of course, you cannot combine this northern part with southern part, because in southern part you have so few drill holes, so the information is really lacking. But it's interesting. In some places you can see the connection to deformation zones. Another big work was done 2004 also by Bura, analyzing and putting together all minerals, because lots of information is in thin sections and thousands of thin sections described. And that was the first and last compilation where these mineral compositions of metabasalts, say igneous rocks with kind of basic composition, and sediments were compiled in different areas. And you see already that you can see actually certain differences here. It's a Tallinn, Western Estonia and Southern Estonian zones. And if you look at, before I show other ones, I try to imagine how the Estonian crystalline basement in Northern Estonia could look like. So I got this match from southern Finland, southwestern Finland. I believe if we scratch off all this sedimentary stuff, we end up with very nice outcrops there. And this is more mythic part, and these mineral compositions are really saying something, but that study did not really follow. It is the next step to understand some additional core of these things. Another line what have been actually active during these, I would say, not active times between 90 and 2018, was to establish more and more geochronological kind of features and understand the age of processes. So here I present just a segment of different kind of melting events. We try to analyze, like in Tapa zone, which was in Northern Estonia, we got these tonalites 1.8 something, but Tapa also had chanokites, which had 1.76 age, which is quite, it was unusual to the old schemes. So, and we have really good measurements also for this much younger events, especially metamorphic after kind of big metamorphism timelines. some reconstructions, those were not never published. We analyzed also these black, metabasalts or kind of igneous rocks with basaltic compositions. And of course, they show something about this origin, but this is quite mixed. So northern and southern parts are more or less saying kind of saying the same story. So you cannot define that it's a very distinctive kind of areas or microplates. So, and this is also kind of compilation of metacaverals. So some people believe those kind of discrimination diagrams, some don't, but it says something like most of these metabasics, metabasalt rocks are kind of like a synclinal way or volcanic arc kind of environments forming. So metamorphic studies are still back in 80s mostly. So it's published in that book, 83 book. We haven't really defined any metamorphic things. So it's simple amphibolites, retrograde granulites, and granulites, and so go on. And even in this compilation by Bogdanova, we actually managed to draw these nice granulites also in very narrow slices of that to compile this Jõhvi zone and compile this southwestern Finnish part, which shows also granulite metamorphic conditions. But there was a study in 2001. It was a master thesis by Ratnieki, and it was Kikas, who actually studied tube drill cores from both sides of Saaremaa fault, which was the east-western fault. So they one part was granulite and one part was amphibolite. So those drill cores were quite close. And those people who can read the metamorphic diagrams, I'm not very good in it, but I can understand maybe very basics. So we can see that these granulites really had a big metamorphic conditions at very high temperatures, while amphibolites were much lower temperatures, and pressures also differed a little bit. So it's also published in 2004, this story. Some knowledge. I tried to understand the big metamorphic kind of melting events and the age, and there is a paper where we managed to put together samarium neodymium ages with uranium lead ages of zircon. So they are very close. So I will say that samarium neodymium method can also work for some cases very precisely for establishing these ages. So those were metamorphic rocks. We have also rocks which are not metamorphosed, so they are posthologenic, as we call it. Rapakivis, nice collection of rapakivis around this piece of earth where living. Latvians don't have rapakivis. Yeah, except Riga, of course. It is half of Latvia, of course, but not small ones. Okay, then the map is, this is not my map, and there is no reference, so sorry about that. But anyway, Estonia has at least 5 these kind of small intrusions, and at least 2 we think that they are multiphase, and another more mafic ones, which are not rapakivis, but the same age. And they are all in a kind of between 1.57 to 1.65 gigayears. So we have redefining the ages. We know quite a lot about the ages already of rapakivi ages, and some are not published even yet. And I managed long time ago, I also took some samples from Riga, because Riga satellite is also attacking Estonia, Saaremaa Island. So, and we have at least 2 or 3 cores with one reserve. I don't know how many meters, some meters perhaps, and I can't even remember from who I got this sample, which was not sampled in a drill ship. But so we got this very old ages also within Riga Batholith 1.66 or 1.67. It's a plagioclase porphyroid, so it needs to be interpreted or what that age actually means. But some new stuff as well. This is Karina sitting in a room somewhere, and she was studying Mariamaa, which is one of these large multi-phase intrusions. And one thing what we have in Mariamaa, we have a huge amount of rare elements in certain layers in the granitic body. So we think it's a 3-phase kind of history, and it has really up to 3,500 even more ppms altogether, these reals. And there you can compare to Finnish ones. So the Mariamaa is, this is not the discrepancy of measurement, but this is variation. This bar is showing variation. Of course, the average is not very big. It's around 1,000 ppm. But yeah, we think that this post-orogenic stuff is quite interesting, but it's the most interesting that even some orogenic stuff is still bearing the same composition as post-orogenic intrusions. So I'm not going into that in very detail because I have to run. And
we're overdue already, half an hour.
Half an hour already.
I don't know.
I started late. Yeah, sorry. I'm trying to just make kind of compilation of ages what we know now. So this is the stuff which we call A-type granitoids. Petrologists usually know what A-type granitoids are. Usually they are also schorstonitic rocks. And we got these kind of age brackets for melting events. The oldest one, 1.8 something, and the youngest one, which is not Rapakivi one, it's something 1.7. And of course, Rapakivi goes down to 1.5 or something like that. So also what we have and we know in other areas where metamorphic rocks are. So the oldest ages, zircon ages, are something 1.9, 1.8, around that, which is precisely what you see in southern Finland as well. So granulite metamorphism peak, I believe, I think this is also published somewhere already. I didn't put the reference here, but the granulite metamorphosis peak conditions were happening 1.78 or around that. And we know also from garnet samarium niobium isotopes that the melting or the cooling down to 600 degrees was happening something 1.73 gigayears ago. And this is a paper by Juha, who is sitting also here. He made a compilation of all ages and trying to also put kind of Fennoscandian known areas in the position. So I would say that it's not much changed. Maybe a little bit this bit has been changed. What was between very late orogenic stuff and Rapakivi. So we have this bit 1.38 there. We have a younger age, so we are slowly moving to progression. So some points of ore mineralization as well as one example. What has been measured during Soviet times is a couple of lead, zinc, those were important, iron as well. So, and I present just a couple of slides about Jõhvi. Jõhvi is sitting there in a northwestern, close to Russian border. So we managed to drill. Jõhvi was discovered 1924, something like that, by Estonian militaries, because the compass was running randomly. And there were drillings, 14 drill holes were done during Russian time, 50s, 80s. And actually during Estonian first independence time, 1937, 38, we actually drilled already 500 and 700 meter holes there. It was nearly 100 years ago, we were able to drill down to 700 meters. And now we are also catching up and more or less capable of drilling these kind of depths. At least 2019-20, there was new drilling, so we drilled 2 holes. We got these 2 new holes in one of these magnetic anomalies, and this gives idea where this Estonian iron is sitting. It's bordered by granites and pyroxenesis, and there is a gabbro body and kind of sedimentary volcanogenic rock there. And this is also old data. As you see, these concentrations of iron are quite low. I was surprised this Latvian iron was higher, definitely higher. So probably no one is not going to boom for Estonian iron. But this is a new drill course and kind of sections. The iron stuff is this darkish area. But it was interesting. During the Soviet times, they actually tried to calculate the body volume, and they ended up with the highest value I have read from reports was 1.5 billion tons of iron oxide. So that's why we also drilled, but we are not able to calculate anything at the moment based on that data. It's an interesting thing also if you look at manganese oxide. It's a shitty figure, but manganese is this one. And you see also very high manganese, but not so high as you have in Steitzele. Was that the highest manganese? Yeah.
Yeah.
And we also try to explain only by garnet, present garnet in that rock. And yeah, iron compositions here in iron 203 version, they are not too high. But yeah, if you put the iron versus manganese, you can actually define 3 distinct groups from the same drill core. So it bears some knowledge, but I'm not able to explain it yet. But probably the new findings were that analyzing, this is the Tartu University study, together with Geological Survey, analyzing these very tiny mineralized veins. You see there are new magnetites, you see this sulfide mineralization, and you see this also gold and silver sitting in those mineralized veins. And even Tartu actually managed to calculate the proportion of gold to silver is 2:1 in tellurides. This is very common stuff. Just one note. I think how many minutes I still have left? Jüri, you wanted to have 15?
Very fast, not already.
You decide. So I could talk 2 hours more. But
I think that also Jüri must have some time to present
yeah,
something.
within 20 minutes.
Lunch coming up, then Brazil.
Oh yeah, lunch. They're giving me if I
You could wrap up slowly, it would be nice.
Yeah. Okay. I skip because those slides will be available later on. I skip this future addressed one of ways of studies, and I get this to the final point. I'm very close to kind of final point. But one thing I still put actually this Paul Bonds and me, we started trying to understand how to use this fractal topology and self-organized criticality things, which comes from physics and they are quite well known, to understand magmatic systems and partial melting. And we actually developed some ways to calculate, because everyone is interested how much has been melted. You have a granulate phases, you have amphibolite phases, so how much is melted during that time? Because it's so important for ore mineralizations as well. You need a thermal engine. You have to know how much melt is there, how much is dissolved of elements sitting in the melt phase, and how much is left. So we ended up, this is 2 Estonian kind of drill cores. You can measure these melted sections like leucosomes, and they are very distinctive kind of amounts of melt, like in a South Estonian granulite drill cores, we got just 20% of melt present, and while in very North Estonian amphibolite, we got 44% of melt sitting in. This I present just as a possible future direction to go to understand what the melting is in Precambrian terrains, and the melting is important. And I finish up now with nice picture, because on the left, that man is still the president of Estonia, and he is interested in drill cores. I would say I'm happy to say that we are not doing completely wrong. So we are sitting here for something okay. So thank you very much. And Jüri comes and talks about geology.
Hello, everyone on both sides of screens. And thank you, Alvar, for leading me these 2 minutes. As you, I started my studies during the Soviet period, but I graduated during the independent period under the supervision of Väino Puura. So meaning that I'm much younger than you, so I can do it within 2 minutes. And actually, my task is easy, because the list of geophysical methods that are applicable for basement studies is quite limited. Seismic and seismological methods have been mentioned here already, as well as magnetic and gravity. And there's one more method that can be used in basement study, that is magnetotelluric method. And that is the only one from the long list of electric and electromagnetic methods that exist. And the reason is in this very sophisticated cross-section, the reason is hosted here in this blue layer, which is called blue clay, which screens all the electromagnetic energy and does not allow the energy penetrate till the basement. This profile about the seismic study of Sovetsk-Kohtla-Järve along this line has been shown here already, giving us the idea about the composition and the depth of the crust. So in Estonia, according to Sadov and Pensina, an interpretation by Ankudinov, the depth of Moha is in Estonia it's in about 50 kilometers. Tarval, who is present here as well, used these data and combined this data with magnetic and gravity, and created a cross section along this line in 2004. And the information is also used by Toivo Korja in mid 90s to compile more depth map of the region. Somewhat more modern methods, receiver function technique. This technique is based on the reflecting back from surface earthquake waves and reflecting them from Moho. Has been widely used in the world, but these attempts in Estonia and also in Latvia are quite recent. The figure on the left side is from a bachelor thesis supervised by Heidi, and is Heidi there? Heidi and Argo Jõele as well. Yes. Well, one can discuss about the quality of interpolation. Personally, I don't like this data there from a Russian what is the station doing? Russian Bulkova, yeah. But it provides some information on the thick crust in Western Estonia and somewhat thinner crust in Eastern Estonia. That is these are the results, the very first results of telluric surveys in Estonia that have been carried out in early 1970s. They did not provide much details. They had many stations. The stations were active for years. This method takes time, and they concluded that there is a conductive layer in a depth of about 75 to 80 kilometers, somewhat deeper in southern Estonia. And they claim that there is another layer in a depth of about 150 kilometers. Well, these have to resist in a crust, so they are not asthenospheric. Another attempt was done in 1998. Where 4 stations were based in Estonia. That is a Baltic electromagnetic array research project all over Scandinavia. Unfortunately, there were no stations in Latvia or Lithuania. However, the interpolation extends to much wider compared to the studied area, but also this map, which is in a form of conductance in Siemens show that conductivity of rock, if we look at the deepest parts, conductance at 30 to 60 kilometers, show that conductivity of rocks is somewhat higher in the western, somewhat lower in the western part, hinting towards thicker crust there as well. These maps look very similar to the previous ones. Also conductivity maps, Siemens per meters. The same story. If we look at the deeper part, Western Estonia is conducting less compared to Western Estonia is conducting less compared to Eastern Estonia. And these data are based on actually on one magnetic storm that occurred in October 2003 and was called as a Halloween geomagnetic storm. And the data from magnetograms from this image network stations was used to be transformed into the conductivity data. And gravity. Some historic moments, actually the gravity measurements, the first ones were done in the mid of 18th century, which is quite a long time ago. Parrot was measuring gravity in the main building of the University of Tartu in early 1830s, and the first gravity network was created by Livlander. All these measurements were done by pendulum systems, providing the absolute value of gravity. The nowadays work is based on relative gravity. That's first, of course, after the Second World War, Maasik was doing quite a lot for the Estonian gravity, but later Geological Survey of Estonia, Estonian Land and the Special Development Board has been active, as well as Estonian University of Life Sciences and the former Institute of Geology at the Academy of Sciences of Estonia. The measurements, the coverage by gravity measurements is variable. The northern Estonia and the islands are well covered, relatively well covered in a scale of 1 to 50,000. And this is just because the Geological Survey of Estonia has been active in these areas, and the gravity measurements were done to help geological mapping. And the very wide wavelengths data of gravity looks like that. It's one of the compilations. We have seen the basement maps beforehand in Alvar's presentation, though one can draw similarities with this data. And the last one, probably the most informative data set, comes from magnetic mapping. The first magnetic mapping were actually made by the Estonian army in Jõhvi, and they measured declinations. Military people are very interested in declination of the magnetic field, by the reasons you know. And this is how the Jõhvi anomaly was found. In 50s, you see this is a situation on the right side. There's a situation in 56. Half of Estonia is not covered by magnetic data. In 59, most of the Estonia is covered by data. There are wide areas, especially in bogs, where there are no measurements. The scale of the map is, I guess, 1 to 500,000. And these were these and also drillings they had were the base to create the very first maps of the crystalline basement. So this map is from 1959. Then in 60s and up to 90s, aeromagnetic mapping as much faster procedure to get the information to go with the ground magnetic mapping. There were various events, various mappings done in various years. Unfortunately, the same problem as the Latvian part has. So part of the information is just in maps, and one needs to digitize it. Metliska and Popko produced most of the aeromagnetic data, and these are in digital format. There are many interpretations made out of that. The data are online by the Estonian Land Board map server. This is on the left side. There's just a map from the server I made yesterday. Also, I can see the similarities between the map and the basement map. And I guess all these details in Source in Estonia that Alvar told us are based on this magnetic map. But one has to consider that actually the everything we see on a magnetic map does not correspond to the topmost part of the basement. And the basement map reflects us the topmost part. So yes, I guess we are in a right way to simplify the basement. And the database is alive. We have done several measurements on ground and also using drones for specific locations. This is a quite good example where the aeromagnetic data, which is expressed by white lines, fits fairly well with the drone magnetic data. The peaks are shifted something like 200 meters only in this case, which is a good result. So just while we concern the distance between the flight lines. This is another example from Uljaste, where the flight lines have been quite sparse and very intensive magnetic anomaly in the eastern part or southeastern part of this map view has not been expressed or was not seen by aeromagnetic measurements. That's it. Not 2 minutes, but but slightly more. Thank you.